So in this video, I'm going to explain how to simplify radicals using prime factorization, which this is a technique that at the Wilson Academy, we have a math debrief session once a week where math candidates come in and we talk about math questions that we've come upon in our clinical experiences or just in our day-to-day lives. And these can be like math puzzles that we're having a hard time solving or questions about the best way to teach kids. So the other day, my clinical partner Brianna and I brought in the question of like, why are kids having such a hard time with questions like, what is the square root of x squared? They're having a really hard time understanding like the relationship between square roots and squares, what a square root actually meant, and just making those connections. So we then spent the rest of the hour of our math meeting talking about radicals and what they mean and how to explain them to kids. And we actually came upon this really cool technique that none of us had ever used before, of simplifying radicals using prime factorization. So I'm just going to explain what we came up with here. So usually, in the way I was taught how to simplify radicals, is a system that involves kind of a lot of intuition and a lot of like logical leaps. So you're supposed to be able to look at this square root of 150 and think, okay, like what perfect square, like can I simplify this? Is there a perfect square that factors into 150 and be able to think, oh, like I know 25 is a perfect square. I know that 25 times 6 is equal to 150. I know that the square root of 25 is 5, so I can take out a 5 and leave the 6 behind. And that's how you can simplify the square root of 150. But that really involves a lot of leaps. Just being able to figure out like what perfect square fits in without a real system, just thinking about it, that's really hard. So what we discovered in our math session was that this can be really simplified using prime factorization, and it's a technique that will work every time, really gives you a deep understanding of what's going on in these numbers, and is a lot less scary and feels a lot less like nebulous. So the system is you just take the number inside of the radical and you do prime factorization. So that means you're finding all the prime numbers that multiply to equal this number. And the way you do that is just by factoring it out. So you just think, okay, like what two numbers multiply to equal 150? And these can be any two numbers. Like the last time it had to be 25 and 6. This time we can just use whatever we want. So I know that because there's a 0 on the end, this can be divisible by 10, and 10 times 15 is equal to 150. Okay, neither 10 or 15 are a prime number, so I keep going. What two numbers multiply to equal 10? 5 and 2. Both 5 and 2 are prime numbers, so I'm done here. What two numbers multiply to equal 15? 3 and 5. Also both prime numbers, so I'm done there. Now I've done prime factorization on this number, and I'm going to rewrite it with all of the prime factors. So we have 5 times 2 times 3 times 5. And now we get to the simplification step, which is anytime there is a pair of numbers underneath a radical, you can pull one out, because that's what a square root sign means. A square root sign means we're splitting up the number, and when we can split the number into two equal parts, we can take one of those parts out. So here we have a pair of 5s, and we can remove one of those 5s. And then what we have left inside is just 2 times 3. Oops, 2 times 3. We cannot remove either the 2 or the 3 because neither of them have a pair. They cannot be split. And so we multiply them back together, and we have 5 square root of 6. So this is the system we came up with in our meetings, and it's a really fun and effective way to figure out if you can simplify a radical and then actually do the simplification.